welcome to Desk of Ladyada.
Hey everybody, and welcome to Desk of Ladyada. It's me, Ladyada. With me is Mr. Ladyada on camera control. So do you have any updates or news, Mr.
I
Ladyada, for
do.
this month?
We got a lot going on today.
Mm-hmm.
So first up, I'm gonna go to your computer.
Okay.
So please go to adafruit.com/Marcintosh.
Ba,
So
ba, ba.
yeah, so this is our month-long celebration of all things retro Mac. There was a cool artist that did this artwork, and then we added our little Adafruit thing. If you go to marcintosh.com, but don't do that because we're just going to show this page, has all the things that you can do. That's a picture of you right there. If you scroll down a little bit from a Quick Take 200.
Ooh.
That's a 27-year-old digital camera. So scroll up a little bit to your picture. Not so bad for 27 years old. And then scroll down a little bit more. So you can see we spent a lot of time on all the different places that you can find Marcintosh information. And what?
Wow.
And then I want you to go to Adafruit's Tumblr. So if you go to tumblr.com/Adafruit or adafruit.tumblr.com, we're trying something new because there's a lot of retro stuff over on Tumblr. Also, Twitter is kind of a shitty place. So we want to put the content where people are nicer and share it, and we'll appreciate it. We're on Twitter. We get death threats. That's just how it is. So this is the uh, post of today that we did. Some history about the Power CD. And then if you scroll down, you can see yesterday's.
I love how big this is. Multimedia kit. I remember this.
Everybody had multimedia kits. And then keep scrolling down. And I really do like the authoring tools on Tumblr. So we posted the Quick Take 200. These are all of our cool photos that we took of the camera itself.
Wow, the smart media cards. They don't make those.
Yeah,
Those are
and
working
then
yet.
keep scrolling. This is a bunch of photos that we took with the camera
Oh.
as well. So on Flickr, it's interesting. They keep track of all the cameras. So the last three cameras, the last three most popular Apple cameras, so there's 50 altogether. It's all the iPhones and stuff. But the last three is a Quick Take 200, 150, and there's another one. And I think the 100. And I think we're the only person on Flickr that has a photo that has the EXIF data from the Quick
Oh,
Take.
really? It had EXIF data back
Yeah.
then. I didn't know that EXIF was
Yeah.
so old.
Yeah.
Okay.
So it's kind of neat. So, for the folks who want to just see this in its glory, so this is the Power CD. I had one of these. This is mine. It plays CDs.
Check out that Centronics.
Yeah, it plays CDs. It has a big old SCSI thing in the back. We posted up the video that kind of promotes this thing too. You'll see that in a second. I just have the beginning footage come in. Has some really neat retro music and stuff like that, and something very unusual for Apple, which is they have a cartoon character that tells you all about what the Power CD is, and they just don't do that anymore. Like eWorld was maybe the most cartoony they got, but like, what is this? It's like a penguin with a
Bow tie?
bow tie, and I just posted up a snippet of what this is and all the things that.
That's quite something.
Yeah, and they did this in partnership with Kodak. So, anyways, the entire month there's going to be cool retro stuff and more. So that's my news. We'll be doing show and tell and ask an engineer this week, and check out all this neat stuff. Maybe a penguin with a bow tie, a blue penguin will stop by. If anyone knows any information about like what this animal's name is, it's probably dead by now because it's been like 27 years.
Stop saying things are dead.
What? No, it's like Mr. Ed, the talking horse. That horse is gone.
Yeah.
Lassie dead. Benji dead.
How they have like the Japanese like
Yeah.
back.
Well, I'm just saying, if you've seen an animal in like popular culture and it's been like a couple decades, didn't make it.
Okay.
It's doesn't last forever. That's why you have to hug and kiss your pets the best you can.
And
Okay.
penguins.
So anywho, what are you working on?
Okay.
Transition from that.
Okay. Ooh. I want you to go to the overhead and I'll show the Okay, so last week some products. So the week before, let's see, the week beforehand I was showing off some. This is kind of weirdly tilted. Why is it weirdly tilted? Hold on, sorry.
Yeah, you're on your own with that today.
Yeah, I do not know. Hold on.
You have to go. The camera tilts the other way.
No, it's like
What?
I don't know. It's just it's got this weird like
No,
skew to it.
so the camera itself,
Yeah,
it twists. No.
this way.
Yeah.
This way. Yeah, I know. No, I think the lens is just I'm not used to this lens.
Okay.
So it's like, oh, you know why? Because it's squished. That's probably why. Sorry. Um, okay, so I've got so I look skinny, but this looks squished.
Yeah, that's because you're looking at it on a different screen.
I know because I'm looking at I can't I forgot for a moment. Okay, so um last week we did we did some feather boards, the feather DVI and the feather e-ink. And then this week what I worked on is because I could get some CAN bus parts again. I released some very old designs that were for CAN bus control. And we actually have a Circuit Python library for native CAN support and a lot of chips, as well as the MCP2515, which is very popular SPI to CAN bus converter. So CAN bus is, I actually don't know a lot about CAN bus, but it's like this, it's often referred to as like an automotive uh, protocol. It uses 2 wires, and you can like hang stuff off of it. And you see here, I've got it receiving messages that are being transmitted by this fellow over here. This is a Feather M4 CAN. That's a SAM E51, which has a native CAN peripheral. And it still needs a transceiver. So you can see here, there's a CAN transceiver. And then you tend to have three or four wires. 3 wires means you have the low, high, because differential, and ground wire. And then sometimes there's a fourth wire for power, so 12 volts. None of these have a buck converter though. So it's just signal and ground, the two signals and ground. So this is a CAN transceiver. So even if you have a CAN peripheral, you still need to have something that does the differential signal thing. And that's almost never done on chip. You tend to have a separate chip that does that, and they're very inexpensive. So this is the TJA 1051, which we actually covered on the Great Search like 2 years ago, but again, we couldn't get it for a few years. Now they're available again. It's like the chip shortage is a memory gone by. And then we've got a little boost converter that gives you 5 volts from the 3.3 because it's 3 volt logic. Sorry, CAN is 5 volt logic, but the input to this is 3 volt input output. You just have ARCs and TX. You can get messages, and then there's a silent. It's labeled here sleep, but it's actually silent. You can disconnect. And then on this board, I have the termination. You can turn it on or off, and the termination is 120 ohms. So CAN bus is not a low power protocol. It's you have to sync current into 120 ohms on either side. So it's kind of hefty, but it's designed to be very reliable. It's kind of a cool. I think it was designed by Bosch. It's a very cool protocol. So this board is acting as a CAN receiver, so it's receiving messages. And the ESP32 series has built-in CAN peripherals. So the chips that have built-in CAN are the SAM E51, all the ESP32s. I think every ESP32 has CAN built in. STM32 F405 definitely has it, and some STM32 F4s. The RP2040 does not, although there's at least one implementation where they bit bang CAN. The problem is that it's like not a full complete implementation. And it's also under GPL, which we don't like to include in CircuitPython. I'm trying to think what other chips. SAMD21 definitely doesn't. You need to use an add-on. Whatever, you can look. NR52 doesn't either. I think you have to have add-ons. So like most chips don't. The ESP32 is kind of an exception that all of them do, and so you can use an inexpensive, couple dollar transceiver instead of, you just connect ARCs and TX lines and you're done for. And the protocol is all handled inside the chip.
Do you want to do questions as they come in, or?
Yeah, sure.
Okay.
Hit me.
I thought CAN bus was 12 volt logic. Does it run on multiple voltages?
It can run on different voltages, but it tends to be 5 volt logic. It's differential 5 volt. 12 volt is just the power that usually goes in. And it is okay to run it at higher voltages. I think it's safe at up to plus minus 20, I think. But don't quote me on that. Look at the transceiver. But the data is like, digital logic. It's differential logic. It just matters what the voltage is. I think it's a little bit like RS-232, where like technically can go plus or minus 10 volts, but what you really see most often is like plus or minus 5 or plus or minus 6. But it's safe to go at higher voltages, but that's only point to point. This one is multi-point. And then this is a FeatherWing that you can use. So like, you have your RP2040, which again doesn't have a native CAN peripheral. An easy way to add it is to use the MCP2515, which was like severely restricted during the chip shortage, was really unavailable. So this design is a couple of years old and like totally just got just delayed. But now this chip is back again, and at the reasonable price of about like $1 or two. There's still people who are like, this is worth $30. No, it's not.
Okay, question. Why would someone use CAN bus if they're not connecting to a car?
It is, it's a reliable protocol that a lot of roboticists use because it's only two wires, but it has like multiple things can send data at any time, right? So you have, what would in I2C be called like multi-master. But I2C, you pretty much is you have one controller, multiple peripherals, and you pull them and you request data. Whereas what's nice about CAN is anybody can send messages at any time, and there's collisions, right? So you have to it detects when there's a collision, you can resend it. That's not true of UART, which is one point to one point, or I2C, where you have one controller, multiple peripherals. So
What's it called CAN?
it stands for control area network or something.
Oh yeah,
So yeah, it's something area network. It's like pan, WAN, CAN,
cool.
CAN, CAN. So the MCP2515 is another way of doing it, and this goes over SPI, so it's you can use it with any chip, and it's like insanely popular. Like everyone has used the MCP2515.
Apparently, First Robotics uses it as a standard, which makes sense.
Yeah, that makes a lot of sense, because it's very reliable against because it's differential and this high voltage. It's reliable against noise, and a lot of motor controllers tend to use it. And then there's an optional DE9, edge mount. So if you solder a DE9 on here, because a lot of CAN devices have a DE9 as the plug. So you could solder that on. But again, I tend to go with the terminal blocks, and then you've got the reset button, and then the transceiver, and then your signal out. So a couple different ways of doing it. We've got the the transceiver board, the FeatherWing, and then you go back to the computer, and I can quickly show what the code looks like. So this is, we have, again, in CircuitPython, we have support. So this is with a 2515. It's very easy. You can receive, you can use the interrupt, which is nice because it'll tell you when there's data waiting. It has a little bit of buffer inside of it. You can send messages quite simply. There's addressing, there's identifiers, and it runs pretty fast. So that's CAN. And then, so this is the CAN wing. So this has gone through many revisions because I decided with the 2515, and then I went to the 25625, and then that was unavailable. So they went back to the 215, and then that was unavailable. So this kind of went through, and you can see like the dates. It's just like, okay, like around 2020, I was like trying to design this, and I just eventually sort of said like, I can't do this anymore, and I just put it on pause. But it's going to come soon. And then for the RP2040, I'm still waiting for my first Bones board, so that's why I haven't published the Bones files yet. But in the meantime, I did design two more. So one, I was working on this CAN stuff. So I was like, let's make a CAN bus version. Again, there is a bitbank version for the RP2040, but it's like, I think it uses a lot of PIOs, and I kind of wanted to like just use something reliable, so have an external chip that does it. So like I didn't want to do any like funky tricks with this one. And I think with CAN bus, people kind of want reliability and something that's like known to work well. So the other thing is I couldn't fit the 2515 and the transceiver in here. Like it's even available on like a TSOP, and I still couldn't fit it. So instead I went with the MCP 25625, which is like literally a 2515 plus a transceiver in one package, and it's just like you literally just wire bond. It's like you just wire it together. It's like the two chips, except it's just one package, and it's in a QFN. And I still have a little boost converter, give me the 5 volts because you still need 5 volts. There's an optional termination that you can remove here, and yeah, so this is a feather can, which I think will be fun because it's like RP2040. And again, it's like I'm kind of burnt out on using SAMD21s and SAMD51s for stuff. I think instead of the feather M4 can, I'm happy to sell it, but this will be cheaper, and I think he's more available. I still think those CAN the SAM E51s aren't going to be available for like another year. So moving right along. And then I also designed the USB host version.
I'll answer a question while
Yeah.
you're
And
doing
I'm
this.
almost done. I'm gonna wrap
So
up here.
yeah, while that's loading up. So question: are people seeing products in the Raspberry Pi product line like available at regular prices yet? I'm seeing offers increase, but still priced unfairly. So we're the only. I'm just gonna, I've been awake all day today. So everybody sucks, and everyone's raising the prices of Raspberry Pis, and we still do a limit of one per customer. But some people decide that that's their invitation to be really shitty to our entire team because no, you can't buy five. And no, you can't play all these games where you start putting different addresses. You can't call our team names and you can't do all that. And like, they're just like real entitlement lately. Like, we're being so fair and
Yeah, it's one
patient.
per. And it's like we actually do one per. And so people are like, how dare you?
And
Actually, I should be special. You're
yeah.
not.
And so, whatever,
You're not a snowflake.
yeah, whatever the Raspberry Pi prices are on Adafruit, that's the price directly from the Raspberry Pi Foundation, the Raspberry Pi Trading Corp. We don't add any extra money on it. It's whatever that they set it to. We don't raise the prices like everyone else, and we limit one per customer so that most people can get it. But like I said, like just right before we got on air, there was like someone on Twitter like threatening us because like we wouldn't sell them more than one, and they were like cursing at our team. So
Don't be like that.
I so the thing is, they pick on us. I don't see them picking on others because like we're available. You're a woman online. We have a cool team that's diverse, so it's like that's their invitation to just be shitty to us. So my opinion, like the prices aren't the real problem. It's just the way people are treating one another because something's not available,
Yeah.
and they're taking it on us. So I don't know. I hope people find something in their life that makes them happy because I don't think getting another Raspberry Pi is going to fix the giant
Yeah.
fucking hole in their soul.
If you're freaking out about not getting another Raspberry Pi isn't going to solve the problem.
Yeah. Guess what? If you have two
That's not the
Raspberry
issue.
Pis, you're still going to be a miserable jerk. Anyways.
So don't be like that.
Yeah.
Tell people not to be like that. Makes us. I mean, we'll still do it, but it's like it's not gonna like we're not gonna be like, wow, you were a total dick. I'm gonna do you a favor. Like it's the opposite, really, if you think about it. Okay, so that's the Canvas stuff, and the USB host. I'll show this really fast before we move on to the great search. So this is the like the kind of fun, weird, hacky feather. So this is the RP2040. And this time I've got a really big boost converter. This is a TPS 601023. So it'll give me up to 1 amp from the battery or USB, whatever you've got this powered from. And then this is a USB-A that you can like plug something into. And we do have a USB BitBang host implementation that we've implemented that it was implemented by Segok, I think, on GitHub, and uh, sorry, they implemented it with PIOs, and then we added that into Teeny USB, and so we have been able to do like mass storage and CDC, and I think even HID USB host. It's not like guaranteed, but it's like kind of fun if you want to do something like a HID remapper, or maybe like you want to do data logging to a USB key, or you want to have a USB serial from some device that's like USB serial only, and you can't get to the serial pins. This could be kind of neat. So I thought this would be kind of a cool, fun, like we've used it on the tester brains that I've showed in previous shows, but now we'd have a feather for it. And then Phil, you sent me this. Is a really cool over on DigiKey, which are leading into the great search. Over on DigiKey, they do have this awesome RGB USB A, so you can see that there is like the USB data pins and power pins, and then there's 4 extra pins that are used for RGB and common anode, so you can like connect up like a NeoPixel driver to this. So let's go. I'll just show this real fast. So let's go to digikey.com. Let's see if I can just rename the URL. No, that's not how it works. Hold on. Let me get the part number. Yeah, so it's 5400266. So check this out. Could be really fun to have like a glowing like a RGB motherboard USB port. Okay, you want to any last question before you move on to the great
So wants to know, is there a rolling window on the one per? No, just right now it's
one per.
We'll reset it later, but
One per.
we just don't know. Um,
It's one per.
yeah, and then I also posted up in the chat. Liz from Raspberry Pi was here not too long ago, and we talked about supply chain stuff, and plenty of pies on the way. It'll just take a little bit of time, and I know what'll happen is, but the people that were really terrible will be like, "Oh, sorry, I was so terrible, but now can I get one?" And like,
Don't be like that.
yeah, like this is why no one wants to like do electronics, by the way. It's like it's not the electronics, it's like 4 or 5 people that are just absolute terror on every company, including us, and mostly targeting us, who think they deserve more than one Raspberry Pi, and they don't. It's not fair. There's not enough.
There's not enough.
Yeah, so like we have something good going on. Anyways, um, what's next?
Well, let's go to the great search.
Yeah, you want to search for like Raspberry Pis or something?
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, more uses our powers of engineering to help you. Yes, you find the things that you need on digikey.com. Ladyada, what is the Great Search this week?
Okay, this week we had a very popular project, the floppy disk USB drive, and it uses a PyPortal. And the PyPortal, which also I can hold on in the shop, I'll show the PyPortal because this was actually
To the computer.
oh sorry yes computer because this actually has the fancy DigiKey logo. This was a partnership project that we did with DigiKey. But it's a little bit old. It is long in the tooth, as they say, which is weird because like people's teeth don't get longer. But anyways, it's a SAMD51 plus an ESP32, and it could use a respinning because this is quite a few years old now. We can finally get more chips, and also like this did suffer a lot from the part shortage because the SAMD51 wasn't available. And one thing that's kind of neat is the new ESP32S3 chips that are out now. So this is like the ESP32 box. Let me just go to a dev board. I don't think we have a dev kit that has a TFT yet. So we have some dev kits. So one of the neat peripherals that's available on the ESP32S3, let me pull up the data sheet, is, oh, this is not the full dev sheet, I think. But one of the interesting peripherals that's available on the ESP32S3 is that it can drive TTL displays. Like, so normally, like on the PyPortal, what we've got is a parallel display that's like 8. Oh, sorry. We've got here is a 320 by 240 SPI or like 6800 or 8080 type display where you're using the frame buffer inside of the display. It has memory inside, and you write to it with SPI, and you just kind of like send pixels really fast. But you write the pixels, and they're stayed on the display. And these displays are great for microcontrollers with low memory because you just say like, okay, I want to write some pixels over in the corner. You split those displays. There's another kind of display where you write TTL data. It's called TTL data. Or dot clock is another way they're called. And so these are, second, TFT 5-inch. So these displays, the 5-inch like TFT 40 pin, these you have to write the data continuously, and the VRAM is stored on the device. So they have like less refresh flicker because you write the entire display at once, like you're constantly rastering the display on. But you have to have something that has a peripheral to do that. You can't bit bang it because you have to be drawing the pixels very quickly. But the trade-off is you can drive much bigger displays. SPI displays, they tend to max out at like maybe 320 by 480. But usually they're 320 by 240. And once you get to 480 by 320, it actually gets a little slow. It's like tough to actually draw that much display. You get a low frame rate. Whereas with these TTL displays, these TFT displays, you can go quite fast. So I thought we'd go over DigiKey. Don't forget, they have these cool RGB USB ports. And let's look for TFT display. Okay, so a couple options here, but even though it's not so literally like a TFT is a kind of LCD, but usually LCDs mean something different. Still, it would be under the optoelectronics graphic display. And one thing that's interesting is that DigiKey has a really wide range. So first off, you've got displays like this, and you can even tell it doesn't have that many pins. So you know that this isn't a TTL, like dot clock style display. This is like SPI most likely, but this isn't always indicated. So this one's like SPI, and then parallel 16-bit RGB. This usually means that it's still like you have to, write 8 to 16 pins, and you latch it. So it still has the memory inside. But there should be a couple options that are bigger. So yeah, now once you get to like this, when you see like that 40 pin display at the bottom, the 40 pin connector, these tend to be TTL. So let's take a look at what these are called, because you can see they're all mixed up together. Like there is, this style, and then there's like this plug-in style, the ones with 40 pins, but this one is SPI. It's still confusing. So let's go over here. So these are called parallel 24-bit RGB, which makes sense because you end up having to have 24 pins for 8 red, 8 green, 8 blue, and then you have VSync, HSync, dot clock, and then display enable or something. So let's look for other displays that are of this type. So I'm actually going to cheat. I'm going to go over here, and I'm just going to select color TFT and parallel 24-bit RGB. And then I also only want active. And there's actually quite a few options. And let's sort by price. So 4.3 inches is another popular size. This was really popular for GPS and like handheld gaming. Please note that there's also a couple times where you get displays and they have like backpacks and stuff built into them. So just watch out for that. There's resistive touch, which you can see this has kind of like a white outline. Kind of see that like whitish outline. So it's a resistive touch screen. And then if you see this, like a black bezel, that's capacitive. And then it has a separate, you see there's like a tail. That's the capacitive touch screen. So a lot of options. You're going to see 4.3 inch, 5 inch, 7 inch. Those are going to be the most popular. 3.5, sometimes you see 320 by 240, but I'll be honest, if I'm doing a 320 by 240 display, I'll go with SPI. So let's go for, I think 4.3 is kind of boring. Let's go for a 400 by 800 display. And let's say it's in stock. I can pick up something today and not in the marketplace. Okay, so it's 35 options. Okay, there's one that we stock. A nice 7-inch display is available. And there's a few vendors, you'll see it pop up a couple times. So DLC, New Haven, NHD, Micro, you can see again, this is capacitive because there's got the it's got the secondary tail. That's the capacitive chip. I'm gonna go with, let me see what's available here. So let's see if I can get something with, maybe capacitive touch. And I think I want a 5-inch display. Oh, I think, hold on. Oops, I misselected something. One moment. This I wanted to look for.
Okay, while you're doing
yeah.
that, how do you even write drivers for these is one of the questions.
Oh, that's a really good question. So for these,
I'll hit some other questions after the segment.
Yeah, so I think I misselected the touch screen.
Okay.
don't forget, you can always remove stuff at the bottom here. For these displays, the driver is almost always written by the company that makes the chip because in a sense there is no driver. Sometimes you initialize them over I2C or SPI just to get them like up and running. But then once they're running, you're literally just like slamming pixels to it as quickly as possible. There is no, I mean, you can set the H-sync polarity and V-sync, and you can set the timing data, but there's no like driver in the same sense that a SPI display has a driver. Okay, so actually I wanted to show a couple more things. So one, 4D Systems has displays, but these have a UART connection. So they're not like a raw, even though it looks like it's a raw display, they're not. And then AZ and New Haven and DLC are the ones that have, oh yeah, this is the one. Sorry, it was resistive, not capacitive. AZ Displays has a lot of options available, so check them out. So they've got the one that I thought was really neat is they have a high brightness 5-inch IPS display. So IPS displays, you know, one thing that you can watch for is when you get, if it doesn't say IPS, like this one doesn't have IPS in the title, that means it's kind of visible only from like 20 to 40 degrees. Whereas IPS, you're going to get like your modern smartphone where like you can look at it from like 80, 85 degrees in every angle. And so the actual display that I liked is this one. Not only is it IPS, but it's nice and bright, 400 nits, and you can compare different brightness, like the backlight brightness will differ between them. And then this one also, there's another option. I think this is probably maybe a slightly different brightness. But this one for $40 is a really good deal because it's got IPS, 800 by 40 pixels, 5-inch display, and it's got that parallel port, the parallel RGB dot clock. For the ESP32S3, note that it doesn't have that many IOs. So even though it's just 24-bit color, what you'll do is ground the bottom 3 or 4 pins of each R, G, and B to get yourself 16. Instead of 24-bit color, you'll have 16-bit color, which is like kind of good enough for most uses. And then those bottom bits, you just ground them or you tie them together. So you don't need as many GPIOs. So just because a display has, you know, 24 bits of input, you don't actually write data at all 24 bits. You just ground the lower bits, write the upper bits, and then you can even technically draw these as like 8-bit color, right? You're only going to get 3, bits red, 3 bits green, 2 bits blue. But because it's raw driven, there's no formatting of the data. Whatever gets written on every dot clock is what appears on the screen. So I'm going to make a board that takes the ESP32S3 and has the 40-pin connector, plug it in, but it's a standard connector and I can swap out different displays to make it a really nice big PyPortal. So I'm going to pick up one of these nice IPS 5-inch displays.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, lined up a bunch of questions.
Yes.
First off, Toddbot, I gifted you a horse on Tumblr. You wouldn't understand, Ladyada. I'm on Tumblr.
I don't know this.
I'm on Tumblr culture.
Okay, you're a Tumblrina.
I gave Todd a horse. You can gift a horse.
Okay.
So I gifted a horse.
Good.
Okay, so here's some questions. Remember the Doom, the little tiny Doom device we did?
Yeah.
So someone wanted to know, is there an update on it? I'll answer this one. The answer is yes. We have a lot of stuff that we're finally getting chips for. So who knows? Could be a future Ada box, could be a future product. Don't worry, it's all happening. So stay tuned. You'll see updates. Next up, Evan recently said that we shouldn't expect a Pi 5 this year. I'm currently playing with a Radaxa Rock 5 Radsha Rock 5B based rock chip, 2 times faster than a Pi 4. Anyone at Adafruit playing with anything from Orange Pi, Radsha, Cadis, or others? These are
we support Orange Pi and I think Radsha.
Yeah.
In Blinka. So let's see.
Yeah, go to circuitpython.org. I think so one of the things that we did because we knew that there's lots of Linux computers out there. Blinka runs across tons and tons and tons of these. So if you want to not have to rewrite all of your code, use Blinka.
Yeah, so Blinka runs on, I don't know if we have yeah, the Rad Zero, RockPi 4C, RockPi E and S. And if you want to add support, we
Oh.
have a guide on how to add support for more chips. So you
Good
can
news.
run our CircuitPython libraries on
Yeah.
it. I'll say there's dozens of these constantly being made, so I don't have them all. But if they're in this list or you want to add them,
Yeah.
you get, you basically get to use all of our CircuitPython
So-
libraries.
I can't tell you who, but a lot of people in industry use Blinka because they're using a lot of Linux single board computers.
So it's a lot of people.
There's a lot of people in industry that use Blinka,
Oh, yeah.
but like, they tell us, but I can't tell anybody because,
Yeah.
they don't want to, that's secret.
Well, it's just a wrapper. It just means like
Yeah.
we don't have to write drivers over and over again.
Yeah. Okay. Someone made an observation. They said, watching all the YouTube videos of all these different boards, it seems like, I'll just paraphrase here. It's just tough getting Linux to run all these. Well,
It's really hard. I mean, like
it's
there's a
Linux to run
distro.
like a laptop made for Linux. Like, there's a lot of
Yeah,
driver stuff.
it's really hard. There's no support, and
Yeah.
and to be honest, even like the RMBN folks were like, we're so sick of it.
Okay.
I remember. I mean, Linus Torvalds, like the last outburst he had was about how much he hated all these boards because
Except-
they were driving him nuts.
Any chance your mini color TFT with joystick, FeatherWing, getting back in stock or being redone?
It's being redone because every part of it got discontinued.
Okay. Does the iSpy connector include pins for touch, or would that be a separate thing if it's a touch display?
There's a touch there's pins on the iSpy for touch. There's the TS chip select, so touchscreen chip select if it's SPI, and there's the I2C pins for
I might not have the context of this one, but maybe you do a little more. These would be dot clock displays. First time I've heard that term was in K-Match's Hack Tablet giveaway.
Yeah, they're called dot clock. I mean, like the weird thing is that they were like kind of the first TFT displays, and so they don't really have a name in a weird way. They're not like SPI displays. They're called sometimes dot clock, sometimes parallel RGB, but there's also like parallel like latched RGB. I just call them like TTL 40 pin. But like TTL means nothing. It's just the logic level, right? So I think dot clock is technically the correct term because they had a dot clock.
Okay. Next, why did they use 2 bits for blue? Is the human eye less sensitive there? I don't know what that's.
Oh, it's just like you pick and choose, but usually traditionally, blue's the first thing that gets dropped, and then green you get to keep, and over like a 565, it's like green has 6 bits or something.
Blinka supports 101 boards. That's right. We just celebrated 100 boards not too long ago.
Yes, we did.
Yeah. Next up, will Blinka work on a Linux desktop?
Yes, it does.
There you go.
Yeah, and you can use like an FT232H
Yeah.
with that to get GPIO.
Yeah, we spent a lot of time on this because we're like, you know what? Why redo everything over and over and over and over again forever?
Yeah. Look, orange
Look
pies.
at. And here's the
Nice.
thing: you can use Blinka while you're waiting for pies to come back in stock, and all your stuff will still work.
That's right. That's right.
All right, let me see if there's any more questions on the other side. We're gonna do any PyPortal updates? Yeah, parts are coming back in
That's
stock.
right, because we're gonna redo it.
When we redesign the PyPortal, will it work with the CircuitPython web workflow?
Yeah, it should. And
Yeah.
and because the ESP32S3, like they have a version with like ridiculous amounts of RAM, I think it'll be really fun. Like you'll be able to do like pretty big projects. They have like versions with like 8 megabytes of PS RAM.
Yeah.
Just super sweet.
And then
Most RAM.
someone said, "Hope life's going good for you and I and little one." Yes.
Oh, thank you.
In fact, she's here right now, and she's just sleeping through the show. So super chill.
Yes.
Nice.
She had an exciting day today.
Yeah.
Very exciting.
Yeah. Today, she tried new foods.
New foods.
First time in her life she had some foods.
Apples.
Yeah.
Applesauce.
Okay.
Okay.
That's
it. Thanks,
We'll
everybody.
see everybody throughout the week. Thank you so much for spending time with us. We'll be seeing you this week on Show and Tell and Ask an Engineer. And don't forget, the entire month is Marchintosh. You'll see some of the lesser known Mac accessories. So, a lot of people have the other retro stuff covered.
Oh,
I'm
is
going
it?
weird.
Yeah.
I'm going super
You
weird.
gotta get your Newton 2000 out.
I'm going super weird. So you'll just see weird Mac related stuff
We have an
from
SC30.
decades ago.
It's true.
Check it out.
Okay, thanks everybody. Have a great night.
Bye bye.
See you on the live shows on Wednesday.